Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. I have been solving math problems for GMAT out of this book here, the GMAT Review, the official guide. If you do not own this book already, purchase one immediately. You should be able to find it at mba.com. The problem that I'm about to solve is the very first problem on page number 181, problem solving, number 209. Let's take a look at it. It says, how many different positive integers are factors of 441? Different positive integers. Integer is just a fancy way of saying a whole number. That's all it is. So let's take a look at it. 441. So I'm just going to start dividing it. Obviously it doesn't go into 2. It does go into 3. How do I know that 441 goes into 2? Well, let me digress for a quick for a couple of minutes. If the sum of the digits goes into 3, then the number goes into 3. That's what you have to remember. For example, here 4 plus 4 is 8, 8 plus 1 is 9. Since 9 goes into 3, therefore 441 should go into 3. For example, let me give you one quick example here. I'm just going to make something up. This number here. What is it? Million, billion, trillion. It looks like 3,516,249,342,000. Does that go into 3? Well, let's find out. As long as the sum of the digit goes into 3, the number should go into 3. Now that's a theory. In practice, actually, you don't actually have to add up all the digits. This is what you do. Okay, anything that goes into 3, this is irrelevant because it goes into 3. That goes into 3. That goes into 3. That goes into 3. And now I'm going to change the color. 4 plus 6, 4 plus 6 is 4 plus 2 is 6, that goes into 3. And 5 plus 1 is 6, that goes into 3. And 2 plus 4 is 6, it does go into 3. That tells me that that number goes into 3. That's all it is. For another example, 4, 5, 7, 2, 9, 3, 1, 2. This time I just made it up without actually thinking anything. Does that number go into 3? I don't know. Let's find out. That doesn't play any role. This doesn't play any role. And then 5 and a 1. 5 and a 1. That's 6. And then 4 and a 2. That's 6. Ah, there you go. That particular number, I'm going to rewrite it so you can see it. 5. 45,729,312 does not go into 3. As a matter of fact, when you try to divide it by 3, you'll have a remainder of 2. You see, that's the only one standing out there. Now, I don't want you to think that it's 2 because it's 2 right there. Had it been 1 and a 1, the remainder, then it'll be 11. And 11, when you divide it by 3, it goes into, you get 9, and then the remainder would have been 2 also. So there you go. So that goes into 3. That was a quick digression there. So let's divide by 3. 4 goes into 3 one time, and then this becomes 14. 14 goes into 3, 12 4 times, and then 2 comes over here, so it's 147. Since 1 plus 4 is 5, 5 plus 7 is 12. 12 goes into 3, so I'm going to try it one more time. 3 goes into 14 4 times, 12, and then 2 comes over here, becomes 27. 27 goes into 3 9 times. Let's divide into 7. There you go. Now what is the question asking? I forgot. How many different positive integers are factors of 441? Okay, different positive factors. So let's do it systematically. First I'm going to do the singles. I don't know how to spell singles. So we will have 1, of course. 1 goes into 441. Then we have 3 goes into 441. 7 goes into 441. So that takes care of singles. Now let's do the pairs. Let me do a different color here for pairs. For pairs, let's see, I need to write it someplace so we can see it. We have 1 times 3 times 3, 1 times 3 times 1, of course we know, but that one does not show it. 7 times 7, 7 times 7, and now I have to do the pairs. So pairs is going to be, of course there's no point starting with 1 here, so 3 times 3, that's a 9, 3 times 7, that's a 21, and 3 times, oh actually we did the 3 times 7 already, and 7 times 7 is 49, so that's the pairs. Now let's do the triples. I need to erase this part here. I don't actually want to erase it, but I need to erase it. Let's do the triples now, see what happens. So we have 1 times 3 times 3 times 7 times 7 from here. And the triples are going to give me 3 times 3 times 7. That's one triple. 3 times 3 times 7. So that's 9 times 7, that's 63. And then we have 3 times 3 times 7, and then 3 times 7 times 7. 3 times 7 times 7, which is 147. What I'm trying to point out here is that you have to go systematically. You have to go systematically and you have to go logically. Of course, you don't have to be so organized and so clean in the exam. Obviously, you don't have the luxury of time, but your thinking has to be systematic and clean. So, how many different positive integers are factors of 441? Let's find out. Let's find out, and let's see if you're alert and if you're thinking. We have 1 is a factor of 441, 3 is a factor of 441, 7 is a factor of 441, so far we have 3, 9 is a factor of 441. Factor simply means that 441 goes evenly into 9. Of course it will go into 9 because, as we can see right here, 441 is made up of 3 times 3 times 7 times 7, so it should go into 9 obviously, 3 times 3 right there. It goes into 21, that's number 5, this is number 6. It goes into 63, 441 should go into 63, I know that because 9 times 7, you see, it will go into 63, 147. What else did I leave out? So far I have 8, I left out 1, what is that? When somebody is asking you what are the factors of this particular given number, there are two things you always have to remember. One factor is 1, because everything goes into 1, and one other last number should be the number itself, 441. 441 is a factor of 441 because it goes evenly into 441. It will go one time. So how many factors do we see? I see 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's the answer. The answer is D. That's all. There are 9 factors of 441. That should say triples. I do not know how to spell things. That's my problem. I suck at spelling. Triples. T-R-I-P-L-E-S. Spelling is not my forte. Anyway, that was it. I hope you found it helpful. Send me an email if you wish to purchase my DVD where I show you the solutions to all the problems in this book that I showed you in the beginning, or if you wish to hire me for personal private tutoring. I'm also in the process of putting together solution manuals down the road. We'll see about that, of the problems. But if you wish to get hold of me for any of the reasons, go to my website at www.prep4gmat.com and send me an email. Alright? Thank you.